Amanda Hafiz, student of Professor John Moses. I am presenting a topic on numerical analysis called partial pivoting. Now, I'm first going to give you a definition of partial pivoting. Partial pivoting is the interchanging of rows in order to place a particular good element in the diagonal position prior to a particular operation. Now, from naive Gaussian elimination, we would know that we need to get the diagonal to start with 1. There must be another 1 there. There must be zeros placed below. Now, what partial pivoting does is it allows us to get exactly the diagonal to be in the right place of 1. Why do we need partial pivoting? Why not go ahead and just do naive Gaussian elimination? Now, take for example, we had a matrix like this one shown here. We notice firstly that we don't have the first element being placed correctly because division by zero is not possible. Not so? So we will not be able to solve this problem by naive Gaussian elimination. Therefore, that is one reason why partial pivoting is needed. Because the definition says that partial pivoting is the interchanging of rows in order to place a particularly good element in the diagonal position to a particular operation. So with partial pivoting, we would be able to change the rows. So the first diagonal here would have an element that will be divided that can be divided and not give you 0. Now, supposing we have another matrix. From the look of it, everything seems to be fine. We have our first element, our pivot element is not 0, so we can go ahead and work. But when we begin to work and we get zeros here and 0 here, we find that that element also gives 0. Now that element should be also 1, right? It should be, so what partial pivoting allows us to do at this stage to interchange rows also. So we can be able to get a value at this diagonal that is not 0. Also, sometimes when you are doing matrices, whether partial pivoting or naive Gaussian elimination, you'll find that you have rounding off errors. Right? Now, rounding off errors are very easy to maneuver as opposed to when you have division by 0. So you find that partial pivoting allows you to handle any type of square matrix better than naive Gaussian elimination.